Good morning, students. So today we are moving to the next part of the chapter. Now we are going to discuss about generation and conduction of nerve impulse. So what it is? Generation and conduction of nerve impulse. So what do you mean by generation and conduction of nerve impulse? Generation means the nerve impulse is generated and it is getting conducted. Conducted means from one neuron to another neuron. So I am touching, the touch sensation is being detected by a neuron, isn't it? And from there through the axon the conduction is taking place and it is transferred to the next neuron, right? So for this conduction from one part to that of the other to the brain, like for example from the sensory it has to go to the brain, from the brain through the motor neuron it has to go to the muscles, isn't it? Effector organs. So this is how the conduction is taking place. Means I am seeing something. So what I am seeing, that message has to be carried. What I am seeing is being carried by my sensory nerves which are present in my eye to the brain, isn't it? Thereafter the brain will interrupt what I am seeing, right? So like that, when you are seeing the things, the nerves are conducting messages from one part of our body to the brain and from the brain to different parts of our body with the help of a mechanism, that is conduction of nerve impulse. Okay, that is what we are going to deal in this topic today. So generation and conduction of nerve impulse, when you are seeing, neurons are always excitable. Excitable means they can get excited themselves. Okay, because when you are seeing, the membranes are in polarized state. Polarized means actually there exists a potential difference, that is the positive negative ion gradient will be there, because of which only this conduction is possible. Okay, now based on that ion channels, when you are seeing the conduction of nerve impulse is taking place because of the permeability between the membrane. So imagine this is the axon. So this is an axon. Okay, so this axon is having permeability to some positive negative charges inside and outside, and this positive negative charges determine the conduction, right? So based on this conduction, there are three points that you have to remember. They remain in three states. What are the three states? One is your resting potential, second one is your action potential, and the third one is your conduction. Okay, so first is what? The resting potential, action potential, and conduction of nerve impulse. So when you are seeing the neurons are resting, means no conduction is taking place, the neuron is just resting. Okay, we call them, they are in polarized state. What do we call them? We call them that they are in polarized state, which means they are not conducting any impulses, actually they are resting. So the membrane is called as what? The polarized. They are polarized. Okay, so this is because actually there is a difference in the concentration of ion across the axon membrane. So this is the axon membrane. So neurons we have learned, isn't it? So that is the axon. So this axon membrane, when you are saying, there is difference in the concentration gradient. So in resting state, the axon membrane, when you see, it's more permeable to potassium ions. The axon membrane is what? They are more permeable to potassium ions. So potassium ions, when you are saying, they can easily come in, and they are impermeable to sodium ions. Sodium ions cannot get in. Okay, so when the axon is resting, the potassium ion can get in, but the sodium ion cannot get in. Okay, that you have to remember. Okay, the membrane is also impermeable to, it's impermeable to negatively charged proteins. So the proteins, when you are seeing, that is negatively charged inside, many are present, and these proteins, the negatively charged proteins, cannot go out because this membrane is impermeable to this negatively charged protein. Okay, so when you are seeing, this is the axoplasm, isn't it? Inside it is what? This is axoplasm. Since many potassium ions are getting in, so here the concentration of potassium ion will be more, right? And when you are seeing the negatively charged that is proteins, the concentration will also be more. Okay, so outside, when you are seeing outside the axoplasm, means outside the axon membrane, you can find they are having what? They are having high concentration of sodium. What they are having? They are having lot of sodium in them. Okay. So the sodium is more and the potassium is less. Why the potassium is less? Because the potassium is getting in and the sodium is out. Okay. So the sodium, since they are impermeable, this axon membrane is impermeable, sodium cannot get in, only potassium is getting in. So the concentration of potassium becomes less and the concentration of sodium becomes high on the outer side. Okay. So that is happening. So there exists a concentration gradient. Okay. And this concentration gradient is achieved by a mechanism called as sodium potassium pump. What do we call them? We call them as sodium potassium pump. Okay. So because of the sodium potassium pump, this concentration gradient is maintained. What is the concentration gradient? Sodium potassium pump, actually what they are doing, listen very carefully, very important this is, it is transporting 3 sodium ions. How many sodium ions they are transporting? They are transporting 3 sodium ion and outside the membrane. Where it is transporting? It is transporting outside the membrane. Pumping means they are impermeable, so some mechanism actively they are transporting what? The sodium outside, and the sodium cannot get in. I told you they are impermeable, isn't it? So 3 sodium ion is pumped out for 2 potassium ion. So how much potassium is getting in? Only 2 potassium is getting in. How much sodium is pumped out? 3 sodium is pumped out. So imagine 3 sodium is pumped out for 2 potassium getting in. So automatically what happens? Outside the potassium ions, when you are seeing, it's becoming less, but the sodium ion is increasing comparatively more compared to what? The potassium ions, isn't it? So what happens is that outside in the resting state they will be in positively charged. Why? Because 3 sodium ion is pumped out and sodium ion cannot get in, isn't it? And only 2 potassium ion is moving in, but 3 is moving out. So only 2 positive charges getting in, 3 is moving out. So automatically the charges, positive charge outside will be more and inside will be less. And since proteins which are negatively charged cannot go out, the negative concentration will increase. So in the resting state, very carefully listen ma, in the resting potential, that is in the polarized state, when there is no conduction, no impulse is transmitted, when the axon is resting, at that time you can find outside it is positively charged and inside it is negatively charged. Who is playing a major role in bringing this one? That is the permeability and the sodium potassium pump. So for each sodium, 3 sodiums when it is transported out, only 2 potassium is getting in, which is making positively charged outside and negatively charged inside. Along with that, the proteins when you are seeing which is negatively charged, since they cannot go out, the negatively charged ions are more inside than outside. So during resting time, when there is no conduction of impulses, outside it will be positively charged and inside it will be negatively charged. Is that clear? Now next what is happening? Listen very carefully. What is next happening is that there generates the next potential, which we call it as what? The action potential. So the first resting potential, I told you how it will be remaining, it will be like this. Okay. Now when it comes to action potential, okay, action potential means what? The action potential means when a axon is receiving, when a neuron is receiving a stimulus, and how afterwards when it receives the stimulus, so in the membrane the potential, the gradient completely change. So they creates an impulse is generated. So that one we call it as what? The action potential. Okay. So in this action potential, actually the membrane is getting depolarized. What is happening to the membrane? It is getting depolarized. Okay. So how it is being depolarized? Listen very carefully what is happening. So whenever a stimulus is applied at particular region, okay, so at the polarized membrane it was like plus outside and minus inside, isn't it? But when there is a stimulus applied in the polarized membrane, wherever the stimulus they are receiving, the membrane is becoming freely permeable to sodium. Sodium can easily get in. When there is a stimulus received, immediately at the site of the stimulus you can find who is getting in. the sodium is getting in, they are rapidly getting inside. Okay, so when there is intake of the sodium is moving in, then what will happen, you know, rapid influx I am telling means they can move in very fast. So in that site you can find the concentration of positive charge inside will be more and outside will be less. Okay, so this leads to what? The rapid influx of sodium. Okay, now the polarity changes, isn't it? So previously it was positive outside and negative inside. When there was a stimulus generated, you can find it is becoming negative outside and positive inside, because the sodium ions are rapidly moving in. Okay, and this state is called as what? The depolarized state. What do we call this state? We call this state as a depolarized state. Okay, so this can also be called as what? The action potential. The action potential is generated. Okay, now imagine I have this action potential is just like a stimulus. So if someone is telling you that you are simply sitting, okay, all of a sudden someone is telling you that you have got first rank, so what will happen? You will get excited, right? Now this excitation will not stop with that. What you will do? You will tell the nearby person, hey, I got first rank. So your excitation is transmitted to the next region. Thereafter she or he will be telling to the next. So like that, what is actually happening is that the stimulus which was received has to be transferred, okay, has to be conducted. Okay, so that conduction of the nerve impulse is the next step what we are going to discuss. Okay, so at the site immediately ahead of the stimulation, so this is the site, B site, this is the stimulated site, isn't it? Here only the stimulus was received, maybe it is touch or you see or you feel or you taste, whatever the stimulus is there, inside it is becoming positive and outside it is becoming negative. So immediately near to that region, just ahead of this region where the stimulation has taken place, you can find outside what it is axon. When we are saying the axon membrane, outside it will be what? Positive, and inside it is negative, right? But what happens is that this means the negativity charged, the conduction is getting transmitted. Okay, so I told you when one is getting excited, there is a transmission. So what happens? This regions become excited. All of a sudden he is listening, isn't it? So what will happen? The positive will be moving in and the negative will be moving out. Immediately after this region, what is happening? The positive is moving in. So this from here, the conduction is passed to this region. So automatically it is like a stimulus now. Now what will happen? The positive will be moving in and the negative will be moving out. Okay. So immediately after that, what will happen is that the previous site is there now, that is the A site. This will come back to normal. They are coming back to the normal. Okay. So why it is happening? This is just short-lived. This stimulus is just short-lived. Immediately when you are seeing the potassium ion is concentration will increase more. Much amount of potassium ion will move out. Okay, and they will result in what? Diffuse outside the membrane, and this potassium ion, when it is moving out of the membrane, all of a sudden you can find here it will become positive and inside it will be becoming negative immediately. Okay, now this place what happened, I told you, since this is acting as a stimulus for this is becoming positive inside and this one will become what? Negative outside. Okay, now the stimulus has to be passed to this nearby region. Now what will happen? The region which is before again will come back to normal. What will happen to them? They will become negative inside and positive outside. Okay. Now what will happen to this region where the stimulus has passed? Here it will become positive inside and negative outside. Okay. So like that you can find slowly from one place to another the conduction is taking place, right? So this is how the conduction of nerve impulses is taking place. So here there are three things which you have to consider. One is the polarized state, in which outside it is positive and inside it is negative. Why? Because 3 sodium ion is pumped out, only 2 is getting in. So because of the negative charge cannot go out, the proteins inside it will be negatively charged and outside it will be positive charged, when there is no stimulus, okay, no impulse generated. Immediately when you are getting a stimulus, the region where the stimulus is received, you can find that becomes what? That becomes permeability they will lose. So, automatically you can find the sodium ions will rapidly move in, and inside it will become positively charged and outside it will be what? Negative charged. Okay. So, in order to complete the current flow from positive, the current will be moving towards negative, isn't it? So, this region acts as a stimulus to the nearby region. So, what happened? The positive will move and the negative will move out. Okay. So, just for maintaining the ion gradient. Okay. So, something has to move from somewhere, there should be flow of electrons in one, if it is moving, the other one they have to lose it. Okay. So, like that this region is transmitting the positive charge to which one? This one. Okay. Now, what will happen is that this region will get excited, right, and they will become inside what? They will become positive and outside they will become negative. Immediately after that you can find from here it will move to this part, and again this will come back to normal, inside negative, outside positive. Like that slowly the conduction is taking place. Okay. So, here what are the three stages? The first one what we saw, what it was? Resting potential. Okay, that is resting potential. This is action potential. Here only the impulse is generated. Okay. So, they are becoming what? Depolarized. Now, next what will happen? Conduction of nerve impulses taking place. So, this region is becoming repolarized. Repolarized means what? They are becoming minus inside and plus outside after some time. Okay. So, like that the conduction will be taking place. So, here you can find depolarization is taking place where there was a stimulus, plus inside, minus outside. Okay. So, next in the next one you can find inside depolarized, this one is repolarized, they are coming back to normal. So, like that the direction of the nerve impulse is taking place and the electrons are moving from one place to another, right. So, this is how the conduction of nerve impulse is taking place. Now, we will just look into the theory part. When a neuron is not conducting any impulse, that is resting, the axon membrane is comparatively more permeable to potassium and impermeable to sodium. This membrane is impermeable to negatively charged protein also. Consequently, the axon plasm, that is axon inside the fluid which is present, has high concentration of potassium and negatively charged protein, and they have low concentration of sodium. In contrast, the fluid outside have what? Low concentration of potassium and high concentration of sodium, isn't it? And they are forming what? A concentration gradient. This ionic gradient across the resting membrane, active transport of ions by sodium pump, potassium pump. Okay. So, they are transporting 3 sodium ion outwards and only 2 sodium ion into the cell. As a result, what is happening? Outside when you are seeing that it is becoming positively charged while inner surface becomes negatively charged. This state we call it as the polarized state. So, electric potential difference across the resting membrane is called as what? The resting potential. This is the resting potential, right. Now, what is happening next? Whenever a stimulus is applied at the polarized membrane, at site A, if the stimulus is applied, it becomes freely permeable to what? The sodium. So, sodium reversal polarity changes, polarity of the site A is thus reversed and it is getting what? Depolarized. Okay. The electric potential difference across the plasma membrane at the site A is called as what? The action potential, which is in fact is called as what? The nerve impulse. At site immediately ahead the axon is resting potential, isn't it? In the beginning it will be resting. So, the sequence will be repeated along the length of the axon. I told you they will start to conduct. Okay. So, the rise in the stimulus induced permeability of Na plus is what? Extremely short lived. I told you the Na plus will get in. Immediately after getting in, the membrane polarity again changes. Thereafter, Na plus cannot get in. Okay. So, Na plus will be moving out and potassium will be getting in, is just short lived. It is quickly followed by rise in permeability of K plus within a fraction of a second. K plus diffuses outside the membrane and restore the resting potential. Again it will come to the resting potential, that is it is getting what? Repolarized, right. More responsive, so that again if one stimulus, I am beating first you are feeling the beating, the second time also if I beat, again you will feel the beating pain, isn't it? So, which means that the nerve immediately after conduction they will come back to their normal conditions. Okay. Now, Listen carefully. What is the next topic what we are going to discuss is that synapse. Synapse means what? Synapse means, you know what is a synapse. This is one nerve fiber. From there the message has to pass to another nerve fiber, right? So when from one nerve to another nerve the message has to pass, there is a gap between these two places, we call it as what? The synapse. Okay. So in this synapse, in the axon ending of one and the dendrites of the other, actually messages from this neuron has to be transferred to this neuron. So this point where the nerve impulses has to be transmitted from one to that of the another in the junction, so there you can find there are two types of transfer possible. One is the electric synapse and another one is your what? The chemical synapse. Sometimes there may be a gap. If the gap is present, actually here you can find in the axon there is a chemical neurotransmitter acetylcholine is released, and this chemical is transmitting the impulse to this. So in that case we call it as a what? Chemical synapse. In some, what is like a wire, okay, one neuron is just, the axon is in connection with the dendrites of the other neuron, they are connected. So like a wire passing the electricity, here the potential difference, the ions are getting transmitted in the form of electricity, how it is flowing, like that the message is getting transferred. Then we call them as what? The electric synapse. Okay. So we can find in electric synapse the membrane pre and post synaptic nerves are in very close proximity. I told you they are very nearby. So the electric current can flow directly from one to another. Transmission of an impulse across electric synapse is similar to the impulse conduction by along a single axon. Just like an axon, the next one is also it is transmitting. Okay, there is no chemical release and all, right? And these is much faster. Here the conduction is much faster. But when you are seeing the chemical synapse between the pre and the post synaptic neuron, you can find what? This is the pre and this one is the post, where from here the message is coming, it is going to this. So there are a chemical, the axon you can find what? The chemicals is present, which is acting as what? The neurotransmitter. Okay. So here the message is impulse is what is that? From the axon terminal the impulse is sent, the chemical is released, and this chemical is acting as a stimulus for the next, and the message is getting sent. Okay. So the released neurotransmitter bind to the specific receptor in the postsynaptic membrane. I told you this is the postsynaptic membrane. So here they are binding, and thereafter the message is getting translocated. Okay. So how many synapses are possible? There are two synapses. What are they? Electric and chemical. In electric, like electricity, the message is getting transferred. In chemical, you can find the message is transferred just like what? A chemical is released, and this chemical is acting as a stimulus for the next neuron, that is postsynaptic neuron. Okay. With this, let me stop for today. Hope you have understood the concept. A small part of this left, which we will discuss in the next class. Thank you.